So, hello everyone. I'm Ludo, the SGU Program Manager in charge of U-space in SESAR. Welcome to all of you. I will now open the webinar with some information. So first, why webinar? It's good to know why we are here. So why are we today? Basically because we want to stay connected with you in that period of time, and we think it would be good to take benefit of all the work done to prepare the working tours that were planned to be done in Madrid. So here you see we have planned 3 sessions. The first one will be this morning, this one. Second one will be this afternoon, and the next one will be on the 30th of April. So first session. The first session is the one that will take place today. You see here the agenda and the presenters. What is interesting to note for this first session that the presenters will show you the large spectrum of the SESAR activities in order to develop U-space. As you will see, we have been working from the definition of the concept up to the demonstration of U-space. In the session 2, this afternoon, presenters will show you the spectrum of the SESAR activities in order to develop U-space. And the session 2, this is another objective. What we'll do is to show you that we were able to propose practical solutions to answer to the various challenges that are related to drones. So here, the presenters will show you what the SESAR projects have found, have developed to answer to practical questions. Finally, the last session will be about the demonstrations themselves. So the aim is to show how SESAR has been connected to the real life, the real needs, the type of scenarios and the type of activities related to the demonstration. So in a very few words, U-space. So I'm not going to make a detailed presentation here, just a few words. U-space is a solution for the safe and secure drone operation in Europe. Its first definition has been agreed in 2017. Since then, the SGU and its partners work to develop its concept and demonstrate its feasibility. So, U-space in SESAR. What can I say? Here you see some figures that are quite impressive. The research work we did was an amazing opportunity to bring everybody together. Startups, research institutes, university, drone operators, service providers, airports, local authorities, law enforcement, civil aviation authorities. More than 100 entities have shared their knowledge, skills, and experience to make this happen. In addition, we have ensured a close cooperation with the European Commission, the EASA, European Aviation Industry, standardization bodies such as EUROCAE, as at the same time, all these entities, all these consortium to ensure that we cover the needs for U-space. They have ensured that new entrants, such as GUDMA, Drone Alliance Europe, or bodies from the telecom industries was part of the game. So here, this is just a family picture. 19 projects in SESAR. You see the name of all these projects, from DREAMS to DOMUS, via Airspace and GovU-space. I will not mention each of them. I just invite you to go to the SESAR JU website for more information. There is 1 page per project, and that will allow you to better understand each of them. A short and complex timeline. As you can see here, this is what happens over the past years. And what I can say that after the definition of the vision, the blueprint in 2017, it was necessary to act and to act very quickly. Almost everything was done in parallel with a short timeline. So you see 2 years for all the projects. This was a big challenge for the projects and the SGU. And here I don't speak about the coordination with the regulation and standardization bodies that were working in parallel as well. So at the end, we had 10 demonstration projects, 8 exploratory projects, 1 project dedicated to the CONOPS, launched together and to manage in parallel. Today, when I'm speaking, almost all of them have delivered their final outcomes, and the SGU is consolidating the results. As you can see here, with the preliminary U-space brochure, in March, the first set of results has been published in the U-space brochure, and we plan to update this document with more information before the summer. By more information, I mean more conclusions and recommendations, requirements, assessment of the maturity of the U-space services, identification of the R&D needs to be addressed in the future. So, because U-space is a solution for Europe, it was necessary to cover a large spectrum of the geographical possibilities and European characteristics. And you know what? We did it. So here you see all the countries in blue that have been participating and the various environments that have been covered in all the projects we had. At the same time, we had to be able to consider a lot of operational and technical questions that were floating in the air when we have started these projects. Some questions such as, can we use a cellular network for the drone operations, or can we have multiple U-space service providers in the same geographical area at the same time? Can we use the existing aeronautical information for the drone operations? So all these questions have been embedded, and here you see the various research topics that we have addressed. So here, my presentation is just an introduction to the webinar, so I'm not going to expand these findings. There will be more details in the near future, but just to show here some key ideas. The first concept of operation of U-space is ready. We have demonstrating the feasibility of multiple service provider. Foundation services have been demonstrated, and so far and so on. All in all, this will be further developed in the final version of the brochure, and the information is already available in the various project deliverables. A very important message that I would like to pass with the webinars and to thank everybody here is that the U-space program in SESAR has been achieved with a strong multi-stakeholder participation. Compared to 2017, this community has been built, and now you see the picture. This is a good example that we had with the CONOPS. The U-space community network grew up to over 500 members over the course of the CORUS project, and resulted in the release of the very detailed and widely accepted initial CONOPS for U-space. To ensure we can go further than that, in parallel to that, the European Commission launched the European Network of U-space Demonstration in 2018, and this is a forum to not only include the R&D aspects, but to include as well the regulatory aspects from the EASA, and to include in the network people and players that not in SESAR. Another message that I would like to highlight from the conclusions we have, even if the consolidation is not closed at this stage, U-space is an ecosystem. So it's true that since the start we say that U-space is a set of services. This is more than that. U-space is a system with dependencies, minimum performance data, and so far and so on. You see here, this is a picture from the Gulf U-space project to show the architecture, and really this is something that has to be considered in the future. My last message here, and this is really something that I think we did with the various projects we had, is to say U-space is U-space, to say no to copy paste. We fully recognize, we are fully aware that U-space and ETM have to live together. Interfaces are required for sure. U-space can learn lessons from ETM. How to manage information, this is really something that we can learn from ETM. As at the same time, U-space has its own specificities. Vehicles are different, infrastructure are different, the service provisions will be different, and missions are different as well. So that's my last message, just to brief you about the content of today and the type of messages that you will hear from the presenters. So as I said, I kindly invite you to go to the SESAR JU U website. You will find the preliminary brochure. You will find a lot of videos that we can show that we cannot show today. As you will see soon, by this summer, more information as we are going to update the brochure with more details, as we are going to publish the project deliverables and others. So thank you for your time. I really hope that you will enjoy this webinar, and I will pass the floor to the first presenter, with Andrew Attali from the project CORUS.
Good morning, everybody. Andrew here, sitting in my office. The CORUS project was a project to build CONOPS for UTM in Europe, later rechristened U-space during the life of the project. And the Podium project is a project which my colleague Anastasia will present in a moment, which put some of these concept ideas into practice in a large-scale demonstration. So the CORUS research project, we were trying to develop a CONOPS based on best practice. We didn't assume that we had all the knowledge. We wanted to build a CONOPS based on consensus, based on taking the best ideas from everybody who was around. The core of the work was a consortium of 9 organizations. We had quite a large advisory board who helped us. We also relied on the members of the other projects, which Ludovic mentioned. There were more than 70 organizations involved in the research projects, well over 100 when the demonstration projects are counted. And then we also had a body of interested people, our network of U-space U-space network group, which by the end of the project were over 600 in number. These people attended our workshops and supported our thinking, gave us comments, inputs, criticized what we were saying in a helpful way. So altogether, the CORUS CONOPS has been aiming for consensus, and we are still open to your comments. You'll see at the end how you can get in touch with me. The core idea in the CONOPS, which enabled the rest of our work, is to divide the airspace into different types. This recognized the situation, and we felt it was most realistic to produce a simple arrangement of 3 types of airspace and deal with these in terms of the services which were being offered in these airspaces and the problems which were being solved by these services. So the first volume of airspace was this X volume, which was a volume for low-risk environments. And in this picture, you can see there's some X on the countryside, over a beach area, over a farming area. So this is an environment where we do not expect much traffic and where the ground risk is relatively low. The next group of airspace is we call Y. And to access the Y airspace, you need to have an approved operation plan. And because of this, Y airspace offers a chance to, as you see in the picture, restrict access. So here the operation plan is a way to ensure that you have permission to fly, for example, over this is supposed to be a little power station. Or it's also for areas of elevated risk. So we would see Y airspace being areas, Y volume being areas where there would be more traffic, there would be a chance of conflict in the air, and the planning which is required for the Y volume allows things like strategic conflict resolution. So the plans will be sorted through and made to deconflict before they take off. The Z volumes are the highest risk, and in the Z volumes we have 2 flavors. We have one where tactical conflict resolution is provided by air traffic control, and this, for example, would be an existing airport. And the second type is where tactical conflict resolution is offered by U-space, and this will typically be the case over urban areas. So in the Z, we require tactical conflict will be tactical conflict resolution will be provided, but we will also require detect and avoid when it is available. In both the Z and the U types, we want tracking. Tracking is important in a Y volume because if you have strategic conflict resolution, it means that you have ensured safety by making sure that the flight plans do not collide with each other. And in order to ensure that that remains safe, you need to know that the flights are following their plans. So conformance monitoring becomes quite important in type Y volumes. In type Z, the tracking is required to allow tactical conflict resolution. Okay, so that's the 3 volumes that we described, and there is a general mapping onto existing airspace classes. Type X is what we expect in the class G. Type ZU can also be in class G, but type ZA is always going to be in a controlled airspace. So the U-space services that we described came initially from the blueprint document and were further refined in the roadmap for the safe integration of drones in all airspace classes, which was a document that was written as a way forward for the ATM master plan. The U-space services were described in the blueprint in terms of U-space levels, and we've shown these U levels by color in this diagram. So U1 were the initial ones, and here we have registration, E-identification, which I'll describe in a moment, and geo-awareness, which is being aware of where the different airspace volumes are, where it's safe to fly. The U2 were the white ones with the blue border or purple border, and the U3 are the green ones, which are the ones which come latest. So in the CORUS project, we divided these into categories. We focused on conflict resolution and safety management. There are many other services which could be imagined which are not mentioned here, services which are commercial activities that will add value, but do not necessarily have a safety dependence. And perhaps the most interesting ones, I see I'm working through my time here, the most interesting ones are the conflict management. As I already mentioned, we will have strategic conflict resolution in the Y and Z volumes, and tactical conflict resolution, which comes in the Z volumes. We also would like to draw attention to the emergency management service, which is a service which brings messages to the drone pilot during flight, messages which might relate to an incoming HEMS flight or something like that. So there are many services. I can't really go through them all today in a few minutes. I would draw your attention to the CONOPS, which you can find, you can download. You might want to take a picture of the screen at the moment. You can download from either of two websites. The Eurocontrol website has a zip file with the entire CONOPS. The SESAR joint undertaking gives access to the Word documents directly, or PowerPoint documents directly. You can also send comments still to us. This mail address is live and will be followed for the foreseeable future. The CONOPS covered quite a number of other subjects, which I haven't touched upon. We had quite some work on social acceptability. So you may find some interesting stuff there to try and get some guidance as to what should be driving the CONOPS. We did quite a lot of work considering safety and contingency, and we had a section about best practices. I think I better stop now and hand over to Anastasia.
Thank you, Andrew. And so Anastasia, the floor is yours.
Hello, good morning, everyone. So as Andrew already explained, Eurocontrol has been leading two projects related to the U-space. Andrew already explained about the CORUS, and I will talk you through the Podium demonstrations project. So Podium is a SESAR Horizon 2020 VLD, so very large scale demonstration. As other projects here during this webinar, it was made to support the U-space services and U-space systems development. So Podium stands for Proving Operations of Drones with Initial UTM. And the project has been running for 2 years during the 2018 and 19. So we have closed the project, and all the materials that we will be discussing in this presentation are made available already. I'll give you the link as well at the end of the presentation. Same as with CORUS, Podium was performed by a consortium made out of 10 different companies and led by Eurocontrol. Also, we have been supported by third-link parties, so smaller companies which were helping us to perform the demonstrations. So if you want to compare CORUS and Podium, CORUS was a theoretical exercise to prepare the CONOPS, when Podium was more a practical exercise with 3 main aims. First of all, to perform live trials and demonstrations. to demonstrate the current state of U-space concept and the systems of the U-space in different operational environments, which are very close to the real operational environment. Then, based on those demonstrations performed, we were able to assess the maturity of the U-space. Basically, we've been working on 4 different areas, or it was on the flight efficiency, safety, security, and human performance metrics. Based already on the assessed maturity, we were also able to provide the recommendations regarding the future U-space development to different U-space stakeholders. What actually Podium means in practice? In Podium, the Podium has performed 5 complementary large-scale demonstrations in 3 different countries. So those countries were Denmark, France, and the Netherlands. In total, we had 18 different operational scenarios, which were combining multiple VLOS, visual line of sight, and BVLOS, beyond visual line of sight operations. And in total, during the 2 years of the project, we have performed 73 actual flights and almost 140 flight authorizations workflows. So the operations were taking place in 5 different sites. So you see here pictures of 4 of them. Each site has had its own specificity and allowed the project team to receive complementary feedback covering various environments. So I'll just briefly explain to you which were the difference of the different environments. So first we had Brittany. So on the top left, you see the Brittany site. So basically there we have performed 5 different scenarios inside of the drone dedicated flight zone. For those who know the Eurocontrol Experimental Center, it's located really close to it. So it's also very close to the Orly Airport and to Orly CTR. And there inside of the reserved zone dedicated to Drone Paris region, we were able to test the different U-space services. The next one is just below the Brittany, Rodez. The demonstrations in Rodez mainly addressed the BVLOS, beyond visual line of sight operations, and they were performed inside in the vicinity of the Class D CTR. So it's Rodez Airport. It's located in the southwest of France. And the focus of those demonstrations were on the UTM and ATM interface. Then on the top right, you see the Odense. Odense, it's in Denmark. In Denmark, we were performing the operations in the Hans Christian Andersen Airport, which is Class G airspace with the FS services. There we also had some interaction with the general aviation. And Markenese Elder, it's in the Netherlands. There we were testing mainly the unexpected scenarios. And in terms of the U-space, you have seen already the slides from Ludo and Andrew where they explained what were the main differences between U1, U2, U3 services. So what we were concentrating on, it was on the U1, U2 services, and we also touched upon the U3 services. In terms of technology, we have used several different technologies which were available on the market. We tried to combine what is available to build the interface which was suitable for all the demonstrations in terms of Podium, and also to build some extra services which were needed to coordinate the activities with the ATC. So what were the results of the Podium demonstrations? So as I have explained already, that the project also has collected and analyzed some validation data. We had 41 post-demonstration questionnaires completed by our participants during the demonstrations. We also had 5 facilitated debrief sessions, and we had some observers and validation experts assessing the demonstration during the trials. So basically, the demonstration results mainly rely on the feedback from the participants. This is the qualitative data. Also, we have collected some quantitative data as well, but the reports are basically mainly made out of the qualitative data. So what are the main feedback was that instead of splitting the services by U1, U2, U3, the members of the consortium have decided that the services which represent the pre-flight services, so the ones that you are using to prepare the flight, were more mature and ready for deployment than the ones which will be used during the flight. Majority of the participants agreed that the single human-machine interface is very useful for the pre-flight preparation. And of course, the system have increased significantly the situational awareness during the flight as well. In general, everyone was happy with the technology being in work, but also we have concluded that there are several aspects that actually U-space community needs to work more on. Those are that there are a lot of data available for the U-space operators, and you never know which data is legislative and which one you can use, which one is the most up-to-date. So it will be useful to have everything in one place. There is no effective procedures and phraseology currently, and the trackers are not performing actually so well, so we will need to look into this subject a bit more. Just also to conclude my presentation, same as with CORUS, all our reports and documents from the project are available on the SGU website, so you can get a copy via the link which is currently on the screen. Together with all our partners, you can see their logos on the screen. We have decided to make all the reports, all the documents that we have been working on during the demonstration to make available. So we also want to encourage you just to make use of those and have a look on them on the website. And to conclude my presentation, I just want to mention that at Eurocontrol, of course, we have finished with CORUS and Podium demonstrations and projects, but still we are working on other projects. So we continue to support European aviation and especially drone and U-space industry. If you are interested in our projects, please visit eurocontrol.int for more details about the current projects. Thank you.
Thank you very much, Anastasia, for this presentation. So here you saw the 2 presentations from Eurocontrol. Now I will give the floor to Pablo Sanchez from Spain, who will speak about the activities in Spain. So Pablo, the floor is yours. You are unmuted, so feel free to speak and to share your presentation.
Okay.
Anastasia, you have to leave your to release the stage and to unshare your presentation.
Hello, good morning. So before starting, I would like to say that I wish that you and your family are healthy. This is a difficult situation. This is the first time in which we are like this. And okay, I imagine that all of you are at home, as in my case. And please, I would like to apologize if there is a cat around here, no? Because it could happen, although this is not related to the drone business. Okay, so, well, as Ludo has said, my name is Pablo Sanchez Escalonilla. I'm working for CRIA, which is the research and development company created by ENAIRE now 11 years ago. I have been participating in the R&D activities in ENAIRE dealing with the Airspace integration, first on controlled airspace, really very research and development activities, and then on U-space. And in this case, in this short presentation, I would like to introduce or to try to sum up the work that we done in ENAIRE, I guess that you know some of this work because we have been participating in international projects dealing with drones, but I would like to provide the vision, the local vision, no? the Spanish view. And for this, the first thing is to show what is the historical context. Of course, all of you know about the SESAR European Drone Outlook study, no? That was published in November 2016. And well, this was a document that recognized the need of urgent actions, no? to take full advantage of the business opportunities of the drone market. In line with this context, as you all know, SESAR decided to publish the U-space blueprint. This was more or less by 2017 by highlighting U-space as a new system in which there will be a set of services that will be used to facilitate the drone traffic management, no? in several environments. For sure you know all these things, but probably you don't know that in parallel, more or less by the same time in 2017, in Spain we published two strategic plans, no? the innovation plan for transportation and infrastructures, and also one strategic plan which was totally focused on drones in Spain. Well, the idea was, of course, to promote the civil drones in Spain and to design a traffic management system that supports these operations. So in some way you can see that from the technical perspectives, there were some similarities, no? And between U-space and our internal plans. And the challenge was to try to combine and ensure that there was a compatibility between the two approaches, no? And well, you can see here the situation with U-space, no? Several services were defined, U1, U2, U3, and in parallel, let's say that in the innovation plan, we were talking about several solutions which could be implemented at the short term, at the medium term, but also some quick wins. No, it was necessary in some way to put in place some functionalities to serve to the current drone operations. So you can see some commonalities, and this was translated in terms of projects. No? So before starting the U-space calls, we did some internal work in ENAIRE, providing an application which was called ENAIRE Drones. It's called because it exists today in order to submit aeronautical information to the drone operators and also to facilitate the process in which they identify where they can fly or not, depending on the law, existing law and existing regulatory framework. No? Apart from this application, even we did a live demo, no, in the GUDMA in 2018 in order to show the APP, ENAIRE drones, but also to see how the services highlighted by U-space could work in the future, especially taking into account the interaction with manned aviation and even with ATM. But okay, it's true that this was a real demo, but we discovered that a lot of work had to be done, and this work was more or less in line with the progress to be done in U-space. And that's why, by taking the opportunity of having some funding and some collaboration through SESAR, we went to the different calls, and we had several projects founded. Two of them are real demos in which we try to test U1, U2, and partially some of the services in U3. As an example, we have DOMUS and SAFEDRONE. And then we have another project that tries to address the medium-term challenges, no? And some issues dealing with the number of operations, high number of operations in environments like in the future, the urban ones, for instance. Just some example and to show well, how we work, I can say that we were not in isolation addressing this collaboration and these projects because we have been working with a wide set of companies, and I hope I didn't forget anyone, but you can see here that we collaborated with the industry, with Boeing, Indra, Everest, GMB. We collaborated also with drone manufacturers as Sea Astral, and well, the current UTM providers were also working together with us, no? As AirMap, Altitude Angel, or Unifly. So the idea is to have a global vision, which was not only locally, in order to define a consistent approach, no, to the issue of operating with drones in the future. Well, and now it's difficult to sum up, no, in 10 minutes. But if I go to the short term, no, basically U1 and U2 services, I could say that for BLOS and BBLOS operations, it is possible, no, to operate, and we didn't discover in our real demos or even in some of the laboratory tests that there could be major concerns, no, that implies that we will not be able to deploy these U-space services. All these operations beyond visual line of sight were managed through what is called the operation plan management, no? Using terminology of the concept of operation of U-space, and also position reporting. No? This was essential in order to manage this set of operations. And something that for us was more important is that we decided to do this by means of a federated architecture, in which there was one role, which was the orchestrator in charge of ensuring that there is an overall picture of the drones traffic management, and in charge of specific safety services, which could be very relevant, no, for safety, as for instance, tactical deconfliction, basically. This is the situation with the short term. And if I go to the U-space solutions that we investigated at medium term, we can say that, okay, to take into account the expected increase in the number of drone operations and the diversity of business models that will operate probably in the urban environments, it will be necessary to evolve towards new technological solutions. But we think that most of the solutions exist today. It's true that there you can find a lot of examples in which, okay, we need to research and we need to find another alternatives for detect and avoid and things like that. But thinking on the UTM systems, we think that we have available solutions that could evolve, no, to respond to the current and envisioned needs. And well, I have included just some examples, some solutions in which we have been researching. The first one is to implement a solution based on what we have called the microservice-based design. This is basically that we tried to decompose the different services, U-space services, into small pieces which are mainly related to the different business. No? And this implies that we can structure the whole U-space in a dynamic system in which within each service you can have several functionalities interacting, and you can have several API and API gateways that allows to manage the overall system. We tested if with this type of architecture it was possible to address the principles of the U-space architecture that were defined by the concept of operation of U-space. And we think that yes, that it's possible to use this architecture to address all these principles, and even it's possible to use this architecture to ensure that we have a flexible system that can in some way be adapted to the demand, no? Because we expect that the demand will be very dynamic depending on the day of operation, depending on the day of the week and the hour, and this implies that, okay, we need to dimension, no, the system depending on the demand in order to allow to be cost adaptive. What we want to say with this is that we will adapt the cost. We will reduce the cost if we don't have so much operations dynamically, no? Which will imply that we will reduce the costs to the final users because there will be no underspending, resources. The other point, which I think is obvious, but we find that it's very essential, is the automation. No, automation is a must for the very complex services. And as an example, we tested the tactical deconfliction service in combination with the dynamic capacity management. And we think that if we want to implement dynamic separation, which implies that, okay, there will be a diversity of drones, diversity of CNS performances, which implies a diversity of separations, it will not be possible for the human to manage this situation. No? It will imply that the support from automation should be really high in the future. This is a must. And okay, trying to sum up, to conclude, as I said before, I think there are no major constraints to prevent the deployment of U-space U1 and U2. I think we can start by having a centralized role in order to ensure safety of the operations, but at the same time having several U-space service providers that will interact with this centralized role. Of course, this does not prevent that in the future, as soon as we have other advanced service, as for instance, tactical deconfliction available to work in a decentralized way, we can progress and delegate some of these safety critical services to the USSPs, no, to the U-space service providers. And but okay, let's go. Let's start because I think the drones market is waiting for our technological solutions. And after saying that, thank you for your attention. I have included also only one link to IMPETUS, but I would like to update this presentation and to send to you, included all the links of the different projects in which we have been participating. Thank you for your attention.
Thank you, Pablo, for the presentation. Luigi is already on stage and ready to go. Just before Luigi starts, I just want to remind, because I do not follow all the messages on the chat, and time to time I see some questions. So please go on the questions tab and add your questions here. Then we'll be able to pick them at the end of the presentation and to answer them. So the floor is yours. We can see your presentation.
Thank you, Ludo. Luigi speaking now, but thank you, Pablo, for the previous presentation. Thank you for joining this webinar. The aim of my presentation is to give you some quick summary of the results of Diode project that has been a very large-scale demonstration performed in Italy, thanks to the consortium under the leadership of INAV and with participation of Leonardo, Telespazio, IDS from an industrial site, Eurousk, and NAIS for the validation purposes, TechnoSky, Avio Group, and Poste Italiane that performed the operations and as a stakeholder of the operations. Of course, we involved other drone operators to perform our trials under the contract of the other Diode partners. The demonstration, of course, it was focused on the U-space services, and the demonstration were relating to the assessment of KPIs such as human performance and safety to investigate, of course, U-space services, how U-space services contribute in maintaining the safety level during the operation and the usability, acceptability by the involved stakeholder. Furthermore, the demonstration was focusing on interaction with ATM. A manned flight was in the demo in one of the two scenarios performed. And the focus was the interaction with involved ATSU, that was the Rieti ATSU, Air Traffic Service Unit, and how the collaborative and procedural interface with between U-space and ATM has been performed. I don't enter in detail on XYZ because of the previous presentation of Andrew. So CORUS defined the concept and the three types of combination of services. The Diode project focused on Y airspace, and for this reason we based our experiment on two main pillars. The first one are the U-space services, where the SORA risk assessment plus strategic deconfliction between planned operations, tracking and monitoring as some emergency management services from one side will assure the spacing between the operation. On the other hand, on-drone capability are really important in order to the overall system to work, because of course the strategic deconfliction full rely on the capability of the drone to maintain the containment of the planned mission. So and the SORA is relying on this in order to not go out the mission and to involve other part of the airspace or other part of the overflown area that are not compatible with the SORA itself. So the combination of these two dimensions, U-space service from one side and on-drone capability on the other sides, were the focus of our development. To do this, we organized two scenarios with 6 contemporary missions involved manned and unmanned flights over the Rieti Airport traffic zone. It has been performed in the 24th to 25th of September last year, and we had a mix of different typical drone operations, from a leisure to the road patrolling, professional photographer, search and rescue, several kind of surveys for precision agriculture, for electric asset survey, or for archaeologistic purposes. The need to start from a drone operation, of course, it's really important, because the focus of this demonstration is to have a quick win of deployment of U-space services and to strongly be linked to the needs of the drone operator. So to be operation-centric. Each of these operations had very specific needs and demand, with very few possibility of intervention, and then the strategic deconfliction is very well perceived for these purposes. So this will allow to have railway survey, for instance, without any interaction during flight, which of course can be understood for the specific drone operator as a waste of the whole mission itself. So the strategic confliction is well aligned with the need of these particular operations. In order to perform this demo, the Diode solution has been developed. So we developed some hook-on device for electronic identification and to position report independently from the telemetry and the drone itself to the back end. The relevant information for tracking the operation itself. Hook-on device were developed in different level of capabilities, starting from the direct remote identification, passing to the 3G connected box, and having as well the professional version with an iridium connection and with satellite communication. All of them have been proved and tested during the demo. We had as well a virtual box, so not a physical box, but a plugin to be installed on the ground control station of the drone in order to obtain and sniff, in quotes, telemetry of the relevant telemetry information to feed the tracking service. From the service provision point of view, we had the drone operational planning, so capability of the portal, of a web portal and an application to file a drone operation, amend it, request authorization, and activate. We have as well a map with drone aeronautical information, so for geo-awareness, and as you can see here, having an air traffic zone, we have several access possible, and depending on the distance from the runway, from the airport, and the possibility to see the traffic, so the traffic information, and the possibility to see the planned mission, that are these kind of volumes depicted here. The service provided to the drone operator during the demo encompasses the monitoring, so the possibility to alert in case of deviation from the planning, so going out to the volume. This information, of course, was also visible to surrounding operations in order to alert about a deviation. Another important service was the emergency management, which was performed, so activated by the drone operator in case of a critical situation like control link loss of the drone or some other emergency that the drone operator can envisage. And this information is shared with the concerned stakeholders. Similarly, the service can be used from the air traffic service unit to alert about the need of immediate landing. So it's a way to have a collaboration with the air traffic service unit and to avoid calling directly the drone operator by phone, but informing about the need to immediately land and to free the area, clear the area. Project outcome and summaries. We demonstrated that CORUS Y airspace is possible. We had, of course, a strategic deconfliction, very focused on the current and short-term availability of the drone market and uncertainty still ongoing. So we didn't take into account in strategic deconfliction the level and of course the time to activate the operation is still an uncertainty. We discovered that drone operator rarely managed to stick on time to take off. So it was, of course, an important feedback to be operation-centric at this stage. Of course, we cannot rely on takeoff time, let me say, of drone operation. That's the basis of the feedback we had. So we demonstrated the importance of the planning and the pre-flight risk assessment, considering that at this stage we didn't introduce many additional services for assessing the actual population density or performing a SORA in case of deviating from a kind of dynamic SORA assessment in case of deviating from the nominal and planned mission. So the importance of the planning and the field assessment at this stage is still envisaged. The collaborative interface with HCC has been evaluated. Of course, the procedural interface is a good mechanism to achieve some operation close to an airport, so in an airport surrounding. But what we discover is that the number of these operations cannot be very big if the air traffic service unit has to contact in case of or being contacted by traditional telephone call as the procedure established are considered. So the collaborative interface is envisaged, even if not integrated in the system, but already with some quick ways to contact, to put in communication the air traffic service unit and the drone operator via U-space service. Still some work to be performed, but not because of the solution is focusing on the quick wins and early implementation as a demo should have. The solution is ready to be deployed. Of course, the regulation, maybe waiting for the regulation that may have some more sophisticated and open possibility, but meanwhile the Diode solution demonstrated that a service can be provided even if without any interoperability needs and not too much from a regulatory perspective. So that's all from my side. If you want to stay in touch with us, of course, the Diode project contacts are here. And of course, Diode stands for D-Flight, Internet of Things for drone environment. And D-Flight, of course, it's the one that is taking on board the Diode research for providing services.
Thank you, Luigi.
Thank you.
So that was the last presentation. I'm now inviting the presenter to join the stage. Then we will enter in the Q&A session, I think. There are a lot of questions, so I don't know how far we'll be able to answer to all of them. Some are specific to some presentations. I already see that Pablo has answers to some of them. I will pick some questions and I will let you. I will let the presenters react. So let's take a first one. So this is for Diode. This is the fresh one, as Luigi was speaking. For Diode, why not use ADSB instead of a new broadcast capability?
So ADSB, we took as a reference several possibilities, no, to the technology. ADSB, we read from bibliography that, of course, it's a good technology, but have some problem in scalability, and for drones is not a recommended technology. Nevertheless, of course, we as a U-space service provider and D-Flight, we are interested in collecting surveillance information from all kind of standard, and ADSB is one of the input we will take into account. But for drones, we don't see ADSB as a scalable solution for networked or broadcast or remote ID. So there are other standards ongoing. So for direct remote ID, there are other technologies, and for networked, there is the intention to leverage the possibility to use 3G connections and as a technology.
Okay, thank you, Luigi. Another question that will be, I think, for you, Luigi, as well as it will be for Anastasia and Pablo, probably. Andrew, feel free to react if you have anything to say. To all project, which technology did you use for tracking positioning, with which accuracy and latency? So here, I think we cannot dig into the details by answering, but maybe to provide the participants with the first answer, which technologies did you use for tracking and positioning?
I answered already in the presentation, but of course, we had positioning received by hook-on device that were based mainly on the, if we want to exclude the direct remote identification, we had some 3G capabilities and Iridium satellite one. And we had a virtual box that has been developed as a plugin for the GCS in order to sniff telemetry data and to be provided to the tracking server, let me say. Which of course elaborated all the source of information to provide system tracks on a map. That's all.
Thank you, Luigi. Something to add, Anastasia or Pablo? I unmute you, then you can react if you want.
Yes, indeed. So in Podium demonstration, we've been using 5 different tracking devices, which were based on 3 different technologies. So those were the GSM, ADS-B over 1090 megahertz, and ultra narrow band L-band. So similar to Diode, we were also using the hook-on devices. Also, we had some built-in trackers as well. About the performance requirements, so this was not really part of the Podium demonstration, but we have noticed that the performance of different trackers was very different, especially in the cases when we had 2 devices at the same drone, that the tracks were completely different. And that's why in the Podium conclusions, we have one of the recommendations that we need further work to investigate on the consistency of drone on tracker performance and also the robustness. Thank you.
Thank you, Anastasia.
And well, in the case of the Spanish real demos, in particular with DOMUS, we use some of the technologies that were mentioned before, and even we try to use the telecommunication network, try to improve with Vodafone the telecommunication network as a support for the identification. But I will say that if you are interested in this, there will be another webinar in which we will talk in particular about DOMUS. And I am sure that we will go into all these details. Okay.
Thank you, Pablo. Another question that will apply to the 3 of you as well. Which technological systems or solutions are used to prevent collisions with sailplanes, gliders, general aviations entering an airspace of U-space, either by accident or because they lost altitude or something like that? So here it's about prevention to prevent collision with manned aviations.
We were in an air traffic zone, so we didn't investigate on a direct link between or a direct cooperation of these other airspace user with the drones directly with U-space, but we relied on a collaborative and procedural interface with the air traffic service unit. So Rieti Airport is a very sensitive area for general aviation, and there are gliders, so with no engine flying over the area. Of course, they are in contact with the Flight Information Service and the Air Traffic Service Unit of the area, and a very strong and clear procedures have been approved for operation in an air traffic zone. So there were some emergency mechanism put in place and some procedure to take in case of interaction of this. So we validated, we demonstrated via the air traffic service unit, but not in a collaborative way directly with other airspace users inside the U-space area. I don't know if I was clear.
Thank you, Reggie. Pablo, Anastasia, do you want to add something?
Just to add that in Podium, we either did it similar to Diode, that it was via tactical deconfliction thanks to the air traffic control services, or in case of Odense, it was just part of the scenario description and some procedural interface rather than using a technology.
Thank you, Anastasia. Pablo, something to say?
For me, it's okay. The answer is similar. I am trying in parallel to answer to the questions in the
yeah,
chat.
I see that. So regarding this point, this question, it's true that this specific question has not been raised by all the project because of the focus on U1, U2 services. Having said that, in the Women Are Free, I think there will be SAFEDRONE. This is one of the demonstration projects which has been more advanced regarding this question. So for the participants who are interested by this, either you go to the SESAR website and see more details about SAFEDRONE, or the best is to be connected for the session. The Women Are Free when Antidio will introduce SAFEDRONE.
If I may complement a bit, is our view is that other airspace users insisting in the U-space area where drones are there should be cooperative. So in any case, we are aiming to interface, for instance, with the DSB and FLARM in order to obtain this information and to make aware of this operation to the drone operators in parallel of course, of a possible interaction with our air traffic service unit. So that's one of the goals. And this is one of the recommendations of CORUS as well.
Indeed. Next question. I see that Pablo already answered this question in the questions form, but I think Anastasia, Luigi may want to react as well. What do ATCOs think about providing tactical conflict resolution to drones in the CTR? Have they been consulted?
I didn't read the answer of Pablo, so apologizing if I'm not in line on this, but regarding CTR, of course, the CTR typically starts very high. So if we didn't go so high, but of course we were working in an ATZ, that is still an area that is very close to an airport and maybe affected by manned aviation operations and other operations. In our case, we were not in the position where the air traffic controller were providing tactical deconfliction to the drone directly. So we were in areas that are not interfering with the hotspot of the airport, for instance. So this has been recognized, the drone operation like an obstacle for other operations. So this means that everything happening for the drone operation is aware, so the air traffic management is aware of the operation, but not giving instruction to the operation. That's in the Diode project. Of course, we believe that this is one of the possibility in case the drone operation is on an hotspot of an airport, but was not out of scope of our project so far.
Yes, but I will add maybe here that it's true that for the controllers the idea was not to manage in some way the drones, no, in that area. But however, it's true that there were mechanisms which were defined, for instance, to act in case of some sort of emergencies, no, and it was possible for the controller to activate an alarm in order to instruct the drones to go out a certain area, no, and so this is the way, because probably I don't know if we share this view, it will not be possible for the air traffic controllers in the future to manage the drones individually, no, taking into account the number of operations that could be in there.
If I may add.
Fully agree.
Yeah, just if I may add that in Podium, we have been using two different setups of UTM and ATM interface. And also what we've noticed in Podium that the feedback from air traffic controllers varies, you know, like some of them, it depends from the personal perception of the drones and the industry in general. So sometimes it was more positive, in other cases it was more negative. What we noticed that what air traffic controllers really liked is that they were able to see more, to have more information. So the situational awareness really increased. And also it depends on which stage you involve the air traffic controllers in the development of the interface. Because, for example, in one of the trials, we were developing the interface and the controllers were involved. It was in Rodez, and at the end they have decided that they would like to have the silent communication. So basically you are able to send the messages, and the feedback showed that they were actually very happy with that.
Thank you. Next question, and I think here Andrew may react as well. What about public acceptance evaluation in the different projects? Is it something that have been taken into account by the demonstration projects and by the CONOPS?
So in the public do you hear me? Yeah.
Yes, we do.
Yeah, in the public acceptance, we in the CONOPS we started to try and make a meta-analysis of other research work, because we didn't have the ability to do large surveys. We didn't have enough resource. We ended up producing some key performance indicators and metrics that could be used to judge public acceptance. And you'll find, if you read the CONOPS, especially volume 3, how we prototyped these. We did some tests using these key performance indicators. I couldn't tell you that they've been systematically applied during the demos, but certainly many of the demonstration organizers were aware of them. So some consideration has probably been given in the demonstrations about public acceptability. But there's a big issue in public acceptability about scale, and our demos have all been relatively limited. I think the bigger questions will come when we come to a full-scale deployment, and then there'll be more need to take public acceptance into account and systematically measure it and deal with it.
It's true that in the CONOPS is not necessarily, unfortunately, the first aspect that we highlight when we promote the CONOPS. Nevertheless, a lot of work has been done in that area, and there are some annexes dedicated to the public acceptance that really deserve to be seen and used in the future.
If I may complement Ludo, in Diode, of course, the public acceptance was not, let me say, a performance put and measured by the exercise. Nevertheless, so during the demo, we organized some info point in the Rieti city in order to understand maybe if people complain about the drone operation, because in some cases we closed some areas, some roads, and frankly, we had no reaction for this. Rieti is a small town, but of course, our experience was that people was more curious than upset about the experiment. Even if for the experiment itself, we had some more safety measure more stringent than necessary because of experimental nature of the demo, and nevertheless we had some, of course, some reaction, but not so negative as we initially imagined. Info point, nobody was complaining, let me say, curious but not complaining. That's there are some articles that of course highlighted some difficulties in some roads on something like that, but no major, so compensated by the innovative nature of the project.
Good to know. Thank you. Next question, that will be, I think, for you, Andrew. how will you determine the capacity of Y or Z airspace?
This is a big subject. This will be followed up in some detail in the ER4 Experimental Research 4 program, which is just kicking off at the moment. The basic idea is that we will keep the drones far enough apart that we're confident that they are safe. So the separation that will be used will take into account the uncertainty in the positioning, in the navigation performance of the vehicle, in the performance of the surveillance, and all these kinds of criteria. So the idea will be that the separation will be sufficient to reduce the residual risk of collision after strategic conflict resolution to some acceptable level. We haven't yet got a number for this acceptable level, but the idea is that we'll keep them far enough apart that they're so unlikely to hit each other that it's not a problem. So that will then determine the capacity. It will be an iterative process that when there is more demand to fly, then we will have to impose technical constraints on the Y volume or the Z volume, which will increase the capacity by reducing these uncertainties. This is described very nicely in the FAA CONOPS as a performance authorization. Exactly the same idea is in the CORUS CONOPS, but a little less precisely laid out. That we will have an imposition of a minimum performance for the surveillance, for example, the frequency of uploading a position report, the allowable uncertainty in the position report, and that will then allow the spacing to be determined appropriately to leave still the risk of collision to be acceptably low. Does that answer the question?
Mm-hmm.
Yes, Pablo, please.
Yes, thinking on the capacity on a certain area, I would like to mention one experiment that we did. Of course, it is one of the advanced services of U-space, the dynamic capacity management. And for us, it was a surprise that, okay, our experience is basically ATM. We are always talking about capacity. We have to constrain the capacity to ensure safety, all those things. And we did an experiment with the dynamic capacity management for drones in combination with tactical deconflictions. And really we found that it could happen that the capacity is not the limit. It could happen that the limit will be the efficiency of the flights or let's say the percentage of completion of the mission of the flights, no? Because okay, you have to think on drone flight plans which will be really very short in the time, which will imply that a set of changes trying to deconflict the flights to increase the capacity will go into a reduction of the number of missions that could be complied with these constraints. No? And for me, it was a surprise and something to be further investigated.
Thank you, Pablo. I think nobody else wants to react to this. It's true that this is an interesting question and that will deserve additional work. A question that, in fact, there are several questions related to this. I see that Andrew already answered, but maybe the other participants would like to answer. Is there a clear and defined role for GNSS? Is it used as a service? Because on one hand, a lot of discussions take place here using GNSS, but we do not see it as such as a service. So what is the place of GNSS for U-space and in your specific projects?
If I may, of course, GNSS is a U-space support service. So it's something that is essential and it's important. As we said on drone capability, I stress the fact that it's important the navigation performance and containment measures capability of the drone. Navigation, of course, is risk-based, and so if we are in a non-populated area, of course, we can rely with solutions that are less constraining about GNSS, and capabilities. But if you go in the urban environment and for more sophisticated and risk relevant operation, of course, navigation performance is quite an important. Accuracy and integrity of a navigation is quite important. So we envisage the development of U-space services to provide to the operator coverage and status of navigation in order to better understand the capability of these external services that are not 100% in the control of the drone operator. So that's an important part of the work still to be performed.
Thank you, Luigi. Do you want to add something, Anastasia or Pablo?
No.
No, okay. And I do not see Anastasia. Anastasia?
Nothing to add. I completely agree with, I think, Andrew's answer in the chat and what Luigi just said.
Okay. Sometimes I ask some questions that have been answered on the question stat because I'm not sure that everybody, that all the participants can see the questions and answers. So when I feel there is something to be shared with everybody, I do it. Just to remind you before, when I'm looking for the next question, that the polls are open. So if you didn't contribute to them, feel free to go. I'm looking for the next questions. There is a question, so I'm not sure we'll be able to answer here, but as it is there, let's ask it, what about the civil military coordination during U-space operation? Is it something that you in your projects have touched or outside your project have touched? For the SESAR, so far U-space is really something which is civil oriented, so the contribution of the military is not there. Now I don't know if on your side you have something to say.
This came up a little bit in the CORUS work. We foresaw that the anti-drone systems would typically have a military dimension, and they will generally be linked to the U-space systems. Detecting malevolent drones is much easier if you can filter out all of the known ones. So there's usually a benefit to an interlinking of anti-drone and cooperative drone management systems. There's also a similar interest in, for example, border patrol and things like that. If you have professional drone activity going on, but there's a risk, for example, of smuggling or something like that, it's very interesting for the military to get warnings through U-space that there's jamming of satellite navigation going on or something like that. So there will continuously be a link between the military and the civilian use of U-space. Military, an important user of U-space. We did not describe any particular use cases for the military in the CORUS CONOPS, but they're just under the surface. The slightest imagination, you can see how it's of interest.
If I may complement, of course, another dimension of civil military, I would like to call civil non-civil, because we know that the drone operations are for civil purposes like railway inspection, electric power line. We know that the use of drone is also for non-civil purpose, like for law enforcement, and maybe they have different requirements of visibility, like the military for the civil in ATM, no? So they are there, but they are not there, or they are visible, but not visible, and so on. So I think also this is a dimension that we have to take care, because of course in planning, of course you need all the demand. You have to understand how this traffic that is there but is not visible, how to manage in this complex situation. We didn't touch in Diode so far, but it's another aspect of civil, in quotes, military coordination, in my opinion.
Thank you, Luigi. Just maybe a small question to you, Andrew. And so counter drones is not part of U-space so far. can we imagine that that could be a new U-space service in the future?
It might be described as a U-space service, but I think the activities which are going on with counter drones at the moment, they're developing quite quickly, and they tend to be very geographically localized. It always tends to be counter drones for an airport or for some sensitive environment. But as we see some standardization developing in that world, it could be that we start to see standard ways of interfacing that to traffic management or other features like that, which are perhaps more the main purpose of U-space. But yes, it could be considered in the scope of U-space, I think.
Thank you. Yes, Bridget.
I do agree. Maybe not the part of shutting the drones, but at least to understand if there are no cooperative traffic, I think in some areas is key and sensitive, especially if we want to enable urban air mobility and we want to have early implementation of urban air mobility, we have to ensure maybe free corridors, for instance, and maybe this is a kind of services that is important to figure it out.
Thank you. There is a question that I will reply to. In fact, this is into other questions. What about the SGU/Eurocontrol cooperation with NextGen and other international projects regarding transparency of U-space operation research? And I know there is another question about how far we can access to the specifications that have been developed by the projects. I just want to make some explanation here. First, and this is why we are here today, as much as possible, we, the project deliverables, will be accessible to the public. So you will see, let's say by this summer, we will finalize the publication of the deliverables. But what is interesting in that set of projects that the project consortiums have agreed to disclose as much as possible their work. So there will be a lot of documentations, a lot of specifications, requirements, and so far and so on, demonstration results that will be accessible to the public, and then to other organizations. This is really what we want to do here. It's to ensure that the first portfolio we had in SESAR, this is the first step, and that the whole community can continue to work and take benefit of it. That for the coordination, the transparency of the results. And already we and I remember I made some presentation either with Andrew or with Anastasia in Kiev a few months ago. We already met international projects to show the work we do, to explain the outcomes and to allow them to take benefit of them, especially for the states, the United States. So there are some cooperation mechanisms to exchange information, and that we are using to share. So Andrew spoke about the FAA CONOPS. I would say that the mindset of the work we did on U-space, and is something I said several times to all the projects, and I'm pretty sure that Luigi will smile in a few seconds. I said the U of U-space means useful, and this is really what we want to do, is to share all the information and documentations to everybody. So that's to answer to the questions about how far you will be able to access to the documentation and how far we share this with international projects. Are there any questions that we did not answer? There are questions that are very, very technically detailed. So I saw that the presenters answer to them. So I guess at the end, Remy, can you confirm that all the questions will be accessible, including the answers? We'll be able to answer offline or not?
That would be great. Yeah.
What we'll do is to take all the questions, the answer, and make them available on our website together with the presentation. But as I said earlier, when you were off, Ludo, the replay to the webinar will also be made available very rapidly.
Okay, fine. There was a question about environmental aspects. How far this is something that we have addressed?
Well, with respect to that point about the environment and public acceptance, I can tell you from the perspective of the work that we did in ENAIRE. No, it's true that we were very focused on the safety aspects. No? And maybe this is consistent with the word that was going to be said by Ludo. But it is also true that if we're going to go with the drones to the urban environments, it will be necessary to fully address all these two aspects that were mentioned. And for that, I think even the European Commission recognized the need, no? Because there is a call that I think it will be closed today, I guess, in which these two aspects, environmental and public acceptance, will be critical to consider the urban air mobility operations, no? Including drones and also manned aviation, helicopters, etc.
Thank you all for this webinar. Especially a big thank to the presenters. I know, and I was part of it. It was not an easy exercise, so I'm pretty sure that we learn a lot from this first webinar, and we will improve of our way of working for the next webinar. The next one is this afternoon. So really, this morning the aim was to show you activities from the concept definition to the demonstration, and to show how they are linked together. I really hope that you enjoyed this presentation, and that you will be excited to go to the next sessions and to access to the project outcomes. So thank you again to everybody for your attendance and for the preparation of this webinar.
Thank you. Goodbye. Goodbye, everyone.
Bye, Luigi. Bye,
Thank you.
Anastasia.
Bye-bye.
Bye,
Thank you.
Pablo, and bye, Andrew.
Take care. Bye-bye.